Alright, hello. This video is going to be reviewing sections 8.4, 8.6, getting ready for the test. Because it is review for each question, I would recommend pausing the video, trying it in your notebook, and then unpausing to check your answer. So here's your first one, give it a shot, and then whenever you're done, unpause and see the answer. Okay, so this is a multiply question, but basically before we do any multiplying, right, generally for fractions you multiply their numerators, multiply their denominators, but we want to cancel before we do any multiplication. Okay, in order to do that, we got to factor. So like n squared can just factor to n times n. This denominator is already kind of factored. The numerator here is, we're going to take a trinomial and break it into two binomials. N and n will make the n squared, and then they have to multiply to positive 5 and add up to positive 6. I believe that's just 1 and 5. And then down here, this is a factoring type we forget a lot about, but they have a GCF of just n. I'm going to pull out an n. Okay, and now I'm going to go through and cancel anything that I can. So this n squared, n times n, the reason I wrote it that way is this times n will cancel with this one. And then the x plus 5's cancel. So up top we just have n times n plus 1. And you can actually multiply them, but generally I'm going to leave my answers in factored form like that. Okay, and then on the bottom all that's left is n minus 6. And that's our cleaned up answer. Okay, one of the harder things on this test is restrictions. And basically restrictions are anytime the denominator is 0. So a fraction bar means division. So we can't have a 0 here because we can't divide by 0. So the numerator can be 0, just not the denominator. Okay, so to find restrictions, look at the factored form. And don't just look at the end. It's any denominator throughout the question. So like if I set this denominator to 0, that would come out 0 when n is 5. Here, if I set n minus 6 to be 0, that would be 6. And then anytime you have a times 0, that's going to make a restriction of 0. Like if n is 0, 0 squared minus 6 times 0 is 0. So the times n makes a restriction of 0. So here are our 3 restrictions. Sorry for the poor handwriting, but we got minus 5, 0, and 6 are the restrictions. So again, that just happens when the denominator is 0. All right, subtract question. Pause the video, give it a shot. Okay, so to make this work, I need a common denominator. And to help, I'm going to start with factoring. All right, so I'm going to factor this first one. The numerator would be d minus 6, d plus 1. Multiplies to negative 6 and adds to negative 5. Everything's positive in the denominator, so it's going to be 2 positive. I think it's going to be d plus 1 and d plus 4. Multiply to 4 and add to 5. Okay, so one of the tricky things here is normally what I would do is if these were my denominators, I would look at this and say I can make the denominators match if I just multiply this fraction by d plus 1. If I multiply the top and bottom times d plus 1, then they'll both be d plus 4 times d plus 1. However, I can get around that here if I realize that these d plus 1's cancel out. So I don't even need to do this over here. Instead of multiplying by d plus 1 there, top and bottom, if I cancel out the d plus 1's in the other fraction, now I have everything over d plus 4. I have d minus 6 over d plus 4 minus 9 over d plus 4. Okay, so now I can just keep my denominator of d plus 4. And then up top, it's like minus 6 minus 9 more. So it's d minus 15 up top. And that is my cleaned up problem. Okay, so that one has a kind of a neat trick where it can cancel like that and makes life a little bit easier. Okay, this is the review one. So this is quite a bit different than what we've been doing this chapter, but we've got to make x squared minus 13x come out to be negative 30. Pause the video and give it a shot. Okay, so the deal here, I'm gonna get 0 on one side and then solve it with the quadratic formula or factoring or the graph method. All right, so I'm going to add the 30. And then since we've been doing a lot of factoring here, I'm going to try to factor it. If this didn't work, then I would use quad form. So let's see, x and x, it should be 2 negative. If it multiplies to positive 30, but adds up to some negative amount, it's negative times negative. We could try like 1 and 30, 2 and 15, 3 and 10. I think that's the one I'm going to need. Okay, so 3 and 10. And now I'm solving. So if I want it to come out to 0, set each little factor to 0. So we get answers of x equals 3 and x equals 10. Okay, and if we weren't sure, you could put them in and check, but they should make it come out to be negative 30 on that one. Okay, division one. Trickiest part here is restrictions, but pause the video, give this one a shot. All right, so basically this is going to become a multiply question, but I'm going to have to multiply by the reciprocal. Okay, and so to save a little bit of writing, I'm going to do this all in one step, but I'm going to take and factor the y squared minus 25, so it's y plus 5 over y minus 5. The y squared minus 16 is like y plus 4 and y minus 4. Okay, and then these two are GCF, so here I'm going to pull out a 2 from the top, and here I'm going to pull out a y. So pull out GCFs, and then when I write it, I'm going to write it flipped. All right, so hopefully this makes sense, but basically this division is multiplied by the reciprocal. So I'm going to put the y times y minus 4 on top and the 2 times y minus 5 on the bottom. Okay, now it's multiplication, so now I just cancel from the numerator to denominator. So y minus 5's cancel, y minus 4's cancel, and I think that's it. So up top we have y times y plus 5, and again we're going to leave it in factored form. The bottom is just a 2 times y plus 4, and again, leaving it in factored form. And I do that just to see if I missed anything and see if it would cancel. Okay, the restrictions here are super tricky. Okay, so normally our restrictions are just our denominators, right? But on a division question, this division means I can't have 0 at all in the back, right? Which means I can't have 0 also in the numerator. Because if I have 0 in the numerator, then this whole back fraction is 0, and then I'm dividing by 0. Okay, so my restrictions actually come from anywhere in any of these parts. Okay, so both denominators and the numerator in the back make restrictions. Okay, so I'm going to go down to factored form. And since it got flipped, it really doesn't matter because both of these make restrictions. So if I look back here at my factored form, I'm going to have restrictions of -4 and 4 for this denominator. Over here, the 2 doesn't make a restriction, but y minus 5 would lead to the restriction of 5. And then up top here, this little expression, the y minus 4 has a restriction of 4, which I already got. And then because of the times y, anytime you have a times y like that, the restriction is 0. So the restrictions here on this one are really pretty tricky. So that's what they would look like. Okay, another subtract one. I encourage you to pause the video and give this a shot. Okay, so we're going to make the denominators match by factoring. So I'm going to pull out a 2 from the front, or from this one, and here I'm going to pull out a y. Okay, and then our denominators need to be anything that's in either of these existing denominators. All right, so I'm going to need a 2 times 2 because of this one. I'm going to need a times y, and then I'm going to need a y plus 2. So I'm taking everything that's in either denominator. That's the common denominator. Okay, which means this first one, I just need a times y. That's what I'm missing. This gives us 5y squared. And then on the second one, we're missing times 2. I'm just going to times 2, gives us 12 here. Okay, now that the denominators match, my answer is going to be that same denominator. And then up top, just do 5y squared take away 12, which we can't actually subtract, so we're just going to write it as that little equation. Okay, and that is our cleaned up answer. We subtracted the two rational expressions. All right, complex fractions. These are kind of tricky, but pause the video, see what you remember here. Okay, so first step on a complex fraction is we want to get it to fraction over another fraction. So fraction divided by fraction. In order to do that here, I need to subtract the numerator and the denominator parts, and I need a common denominator. So I'm going to take this times x, top and bottom, gives us 5x over x. And then the bottom, same thing actually. I'm going to take it times x. So the first fraction stays the same, but then I have 3x over x. Okay, and the whole point of doing that is now we can actually subtract. So up top I have 2 minus 5x over x. And in the bottom we have, let's see, 6 minus 3x over x. Okay, now we got it here, which is what we wanted. And now this big fraction bar is division. So I'm going to make it into a division question. So I'm going to do 2 minus 5x divided by 6. No, what am I doing? Okay, so it's the top fraction divided by the bottom fraction. So it's 2 minus 5x over x divided by 6 minus 3x over x. That's what this big fraction bar means right there. Okay, now that it's division, I'm just going to multiply by the reciprocal. So keep the first fraction the same. And then I'm going to multiply by x over 6 minus 3x. And then think of them as quantities. So we have this quantity and this quantity, but both have a times x, so those cancel. So we're left with just 2 minus 5x all over 6 minus 3x. And that's as simple as it gets. Those don't cancel because they're quantities and they don't match. So that's our cleaned up final answer. Okay, solve one. So pause the video, give this one a shot. Okay, so on solve ones, if there's multiple fractions on one side, I want to get the denominators to match and then multiply by that denominator to wipe it out. Okay, so this x squared minus 9 is really like x minus 3 times x plus 3. Okay, and what that helps me realize is my common denominator for this is going to be x squared minus 9. Okay, so I want to get all these denominators to be x squared minus 9. Okay, so that would mean I need to take this fraction times x plus 3 to top and bottom because it's missing the x plus 3. And then this one is missing the x minus 3. I gotta take top and bottom times this one times x minus 3. Sorry, that's hard to fit in there. Okay, and then once we do that, all the denominators will be x squared minus 9. And I'm going to write it in the multiplied form just to save a little bit of space. Right? This x minus 3, x plus 3 is really the same thing as x squared minus 9. Okay, so up top here we have 2x plus 6 if we distribute. And in this one we have 4x minus 12. All right, and then here's the magic is once the denominators match, those are all divide by x squared minus 9. So if we just take this times x squared minus 9, these divides will cancel with that times. Zoop, zoop, zoop. So we're just left with the numerators. 2x plus 6 minus 4x minus 12. So I got to minus this whole numerator equals 8. And now it's just a bunch of algebra to clean it up. All right, so from here, I would probably distribute this negative to both parts. So you have 2x plus 6 minus 4x plus 12 equals 8. Combine like terms, 2x and 4x is 6x. Positive 6, positive 12 is 18. All right. Oh, wait, no, this should be minus 2x. I messed up. Now minus 18 from both sides. Divide by negative 2, and we get 5 as our answer. Okay, That's it. Thanks for watching.